Right, we need to remember our rules of logs here, and I'm just going to jump straight into the one where we're minusing them. If you have log A minus log B, and this is to any base in fact, then it becomes log A over B. So in this case, our answer is simply going to be log to base 3 of 4x plus 7 over x. Because in my case, A is 4x plus 7 and B is x. Part 2, hence solve this equation. Well, it's going to become, we can again, we've already sorted the left hand side. It's equal to this, and that equals 2. Now I'm in the position to undo the logs. It must be that the base, which is 3 to the power of 2, equals 4x plus 7 over x. You could alternatively raise both sides to the power of 3, and then these cancel out because they're inverse operations, and then get the same thing just swapped around. But make sure you can undo logs and get to this sort of thing. I'm going to multiply through by x now, so 3 squared is 9, so I'm going to get 9x equals 4x plus 7, and I'm nearly there. Minus 4x from both sides, 5x equals 7, x equals 7 over 5. Brilliant. We're then asked to use the trapezium rule with two strips of width 3 to find an approximate value for log to base 10 of x between 3 and 9. Alright, I think a good idea is, you don't have to get your sketch super accurate, but log to base 10 actually looks a little bit like this. And I'm being asked to integrate between 3 and 9. So essentially I'm being asked to find this area here. That's my definite integral. Now, I do actually have the formula for the trapezium rule. Here it is. So you don't, the sketch helps, but here's the key thing. So for us, we've got that b is going to equal 9. That's my upper limit of the integral. And a is going to equal 3. And then we're told that we've got two strips, so splitting it into 2, although they have to be equal in width. Well, they don't have to be, but they are in this case. So n is 2. And from that, we see that h is going to be 9 minus 3 over 2. That's 6 over 2. It's going to be 3. And from that, I'm going to get my x naught. I'm going to add 3, my h value to x naught to get x1, which is 6, and then finally x2. Now they're not in the formula, but they're going to allow me to get my y values. So it must be for 3 intervals that my integral, which is log to the base 10. Okay, this is going to be approximately a half times 3 y naught plus y2 plus 2y1. I've just replaced n by 2 essentially, and I only need to consider this part, none of these. Okay, so this is going to equal 3 over 2. I'm just going to use a normal bracket now. Actually, no, I won't. I'll keep using the curly bracket. So y naught is going to be my value of y when x is x naught, so when x naught is 3. If I substitute that in, remember my function is log to base 10 of x. It's going to become, I could use a calculator, but I'm going to do so in a minute. It's going to become log to base 10 of 3. And then I'm going to add, when I put x2 in, it's going to be log to base 10 of 9. and then it's going to be 2 lots of log to base 10 of 6. Now, I'm asked to give my answer to 3 significant figures, so I think I could actually combine this into a single log, but let's not worry about that here. I'm just going to add these up. Just trying to remember if there's another log button. Okay, I can't see it right now, so let's just go with it. So it's going to be, times this by 3/2. It's going to go straight into it. 4.4814. Which to 3 significant figures will become 4.48.